So now we move to the first topic or first section of today's class. So we are going to talk about simulation approaches and a level of details. As you probably catch up from the title, it seems that there are different approaches how actually we are able or how we are able to represent the model. And according to the title, most probably you catch up that it seems that levels of detail is playing a significant role in helping us to understand what a simulation approach should be selected. So in frame of this topic, we are going to dig inside and we are going to understand what approaches exists and what is the essence of each specific approach. So now we are going to explore simulation approaches. If you would try to search in the literature, you would easily find out that there are three, I would call them classical simulation approaches. So talking about the first one, and to be honest, the oldest one, this one is an approach which is called a system dynamics. It has been proposed by the researcher J. Forrester. Next, we are going to look to the approach which has a title, a Discrete-Event Simulation, and as you see, we are going to explore the following approach in the details, because it's, to be honest, the main approach which is utilized to simulate production and logistics systems. And the third approach, I would say the youngest from all three, is the approach which is called agent-based simulation. And a following approach, again, we are going to explore with the details. While we are not going to talk about a system dynamics approach, if you are interested to read what is the essence of the approach, I would like to pay your attention that here is the link, read more, which would give you additional information about the mentioned approach. Okay, so let's try to go deeper inside. The following slide illustrates how different simulation approaches operate at different levels of abstraction and detail. Please don't be confused by the word abstraction. Here, a word abstraction can be substituted by the word simplification, meaning that we are talking about levels of simplification and level of detail. So the first one, which is in the top, is a system dynamics. A system dynamics is the approach which focuses on highly aggregated structures such as feedback loops and strategic influences. It's typically used at the macro and strategic level of decision making. The next one is the discrete-event simulation. According to the picture, we could see that it operates on mesoscopic or tactical level of a decision making. So a discrete event simulation is focused on modeling processes, cues, resources, and event-driven behavior. And finally, agent-based modeling operates at microscopic or operational level, where individual entities and their interaction are explicitly represented. So, in overall, the key message of the following picture would be that we have different approaches and all of them operates on a different level of details. Of course, it's quite clear that everything depends from the system type, from the goal which we would like to reach, and of course, as we have discussed during our previous class, what kind of data is available for a simulation. So, a following slide and the following picture explains the relationship between the levels which I have mentioned before, so macroscopic level, mesoscopic level, and microscopic level. So the picture not only demonstrates them separately, but also tries to explain what is the relationship between the mentioned approaches. So as usually on the top we see macroscopic level, which takes a holistic top-down perspective. Here we focus on aggregates such as populations, averages, and global indicators. This is the natural domain of system dynamics. So in the middle we have a mesoscopic level which focuses on processes and workflows. So this level represents how entities move through activities and resources, which corresponds to discrete event simulation. And finally, at the bottom, we see the microscopic level, where individual entities act autonomously and interact with each other. This bottom-up perspective is a foundation for agent-based simulation. So, to be honest, I like this picture very much. It has been adopted from an AnyLogic website, so you could easily find it in internet. As you see, we're still talking about abstraction scale or simplification scale, but now we see not the specific approaches, but different domains or different types of a system. Of course, the information which is represented here is not the rule. As we have discussed, everything depends from the goal, which finally we would like to reach. But as you're able to recognize that different types of systems from different domains usually are simulated on a different level of abstraction or simplification. So, at example, strategic questions in logistics, transport policy, or market planning are usually modeled at macroscopic level. Operational systems such as warehouses, terminals, production lines, and service systems are usually modeled at the mesoscopic level. Highly detailed systems such as traffic flows, pedestrian movements, and vehicle behavior are modeled at the microscopic level, where individual entities and their behavior are crucial for representation. So, to sum up the following section, we could make the following points. So, different simulation approaches model the same system from different perspectives. System dynamics is best suited for macroscopic level of decision making, strategic questions, huge investments, and so on. Discrete event simulation focuses on processes and workflows, typically at the mesoscopic level of decision making. And finally, agent-based simulation allows us to model individual behavior and interactions at the microscopic level. The key principle is that the level of abstraction must always match the modeling purpose. As we have already discussed, the modeling purpose here, or modeling goal, plays here a very important role when you need to decide which approach you would select to develop the model. And finally, more detail does not automatically mean a better model. So, meaning that if we are providing a lot of details, probably we will spend a lot of time and the cost of our model will be huge. That's why we always need to balance how much of details we are going to include and what would be our efforts to complete the simulation.